we are going to look at, we're going to be given a function here and work with it analytically to do some answers about f prime of x and f of x. Just using the skill sets that we have. Let me change this view right here to 100% so we can see this a little bit better. So for each of these, we're just going to follow the steps here. The first thing we're going to do, if we're given a function, one of the things that we can do is to find f of x. That's number one. We're going to find f prime of x. So we have f of x. So f prime of x would be 3x squared minus 6. Okay? Now, after that, we're going to find the zeros of f prime of x, because this is where we get information about relative maximums and relative minimums. Okay? So f prime, well, like basically this gets set to equal to 0, so 0 equals 3x squared minus 6. I'm going to take my 6 over here, make it positive. 3x squared. I'm going to divide both sides by 3. I get x squared equals 2. Take the radical of both sides. I get x equals plus or minus square root of 2. So I got my zeros. So I'm going to write x equals, curly bracket, negative square root of 2, and positive square root of 2. So I'm going to create a little sketch of this derivative. So I'm going to do a little line here. Now, oops, my bad. Do a little line here. Okay. And I'm going to make a little number line. So I have 0. I have negative 1. I have 1. I have somewhere in here square root of 2. I have negative square root of 2. I have 2. And I have a 2 right here. So negative 2. So just create a little number line. This is my x-axis. And the first thing I want to do is I'm going to circle these zeros. Circle or highlight? I'm going to highlight them. Okay? I'm going to highlight them so I can see them clearly. So right here hits the x-axis. And these are the points of my relative maximums and my minimums. All right? So what I want to know is, where is f prime of x? Is it above the x-axis, or is it less than the below the x-axis? So is it above? So is the next thing. So I want to work on whether or not f of x is increasing or decreasing. And if it's both, I want to know where that is happening at. So if it's increasing when f prime of x is greater than 0. It's decreasing when f prime of x is less than 0. And remember, my minimums and maximums is when f prime of x equals 0. So here, all right, so now I could set this equal to some positive number. That's not going to do what I want it to do. So what I'm going to do is check these x factors. So I'm going to check f of x at these x values. So, and I'm going to check f prime of x. So f prime of negative 2 f prime of negative square root of 2, that's 0. I already know that. F prime of negative 1, f prime of 0, negative 6, f prime of square root of 2, and f prime of 2. So I don't know what those values are. All right? And then I'm going to check for f. I'm going to check for f. So I'm going to say f of negative 2, f of negative square root of 2, f of negative 1, f of 0, f of square root of 2, and f of 2. So this I know is going to be 1. That's an easy one. Okay? So what I would do is I would just go use a calculator. So we're going to use a TI-84 today and not, let me see if I can have it on here. See if I have it. Okay. Oh, my calculator is not hooked up. Hold on. Let's see. TI-84. TI-84. Oh, I don't have it. It sucks. So I guess we're using Desmos. So Desmos. That kind of sucked. Okay, so I'm put f of x in here. F of x equals x cubed. And I could just do this to kind of figure these things out, but I'm not going to use the graph directly. I want you to see it analytically. So I'm going to get a table of values there. Hold on. Okay, so I put it in, right? So now I just need to write these values in. So I minimize that a little bit so I could do that. So I'm going to go write the values for f in. And let's see what I got here. I have equals 5 equals 6.65 equals 6 equals 1. No, this equals negative 4.65, and f of 1 equals 4, f of 2 equals, let's go see what f of 2 is. Didn't have it. 2 is negative 3. Okay, it's negative 3. So I just want to have these values on hand. So I'm going to do something with them. And you should be doing the same thing as I do. Okay, now for f of x, I can just literally type in f prime of x once I type in f of x in Desmos to get the derivative, to graph the derivative. So f prime of x, I have 6, negative 3 at 1, negative 1. I have 0, and I forget to do f prime of 1, which is negative 3, and I have 6. So I have those values. And it took a little while. That's okay. So let's look at when is, let's highlight when my y values are negative for f prime of 0. So it's between negative 1 and 0. So I'm going to do that with green. So here between -1 and 1, all of my y values. So between there, I'm going to say that f prime of x is less than 0. So over here, f prime of x is greater than 0, and over here, f prime of x is greater than 0. So let's check with my values of if that turns out the same way with my values of the function f. So at -2, it's positive, and it's still positive. It looks like it increases, and it increases all the way up to here. And here, f of x equals 6.65. Okay, so this is a maximum. So I have plus goes to 6.65. All right, so I'm going to say relative maximum at square root of 2, negative square root of 2, comma 6.65. All right, and I'm going to put y, this is a relative maximum, in a second. So my y values, they start decreasing and then they become negative when they cross over 0. Actually, they become, y values right here, they become negative when they cross over -1 for f prime of x. When I get past 1, they start back being positive. And at square root of 2, I have a 0. If I go down here, this one is -4 point, and f of x has a relative minimum at this 0 when f prime of x has a 0. So f of x has a 0 at it equals -4 points. It's like 1. Okay, so I have a relative minimum at square root of 2, -4.1 something, according to what I got from that graph. You could calculate this. You could say f of square root of 2, and you could say f of negative square root of 2 to get the exact y value for that. This y value happens to be equal to this, and this y value happens to be equal to this. Now, why does it have a relative maximum? So let's look at what's happening to f prime of x. I'm going to erase some things real quick. So here's the thing. Positive relative maximums occur when because f prime of square root of 2, negative square root of 2, and make that smaller because, sorry, there we go. So f prime of negative square root of 2 is a 0 for f prime of x. First of all, that's why I know it's relative maximum or minimum. And y values change from positive before that to negative at negative square root of 2, at x equals negative square root of 2 for f of x. So what do I mean by that? Well, if I look at these y values, I have a positive at -2, I have a positive I have a 0 right here, and then I have a negative right here. So here's my 0. It changes from positive to negative. The y values change from positive to negative. If I look, they change from positive to negative. If I look here, before this next 0, this is my 0, right? What's happening to the y values? They change from negative to positive. So if I did this on the map, I would have from a negative to a positive at 2. All right, negative to a positive. Now, that means from negative to positive, and it's at 0 right here, at the 0, because f prime of square root of 2 equals 0, that means it's a 0 for f prime of x, and y values change from negative to positive at x equals square root of 2. So what I needed to do here was, one, use f to determine what the point was, what the location of the relative maximum minimum was for both of these. And then what I need to do is look at the actual y values for the numbers before the 0 and the numbers after the 0 to tell me what kind of relative maximum I had, or what kind of extrema did I have. Did I have a maximum or did I have a minimum? A lot of talking there. Now look at this right here. Let's determine if f of x is increasing or decreasing. So for increasing, then f prime of x is less than 0. No, greater than 0. So let's find that interval. So f of x is increasing when f prime of x is greater than 0. So greater than 0 right here from negative infinity to 1. So parentheses and union 1 to positive infinity. Now decreasing when f prime of x is less than 0, f is decreasing on intervals from negative 1 to 1, and that's it. That's all you do. So we're going to try one more. You can do this one for homework. We're going to try a trig function here. All right. So trig functions, you want to definitely use like 0 and in terms of pi and stuff like that. So let's first find my f prime of theta. I have 1 plus 2 cosine of theta. All right. So we're looking from 0 to 2 pi. So whenever we're going to find the zeros, 1 plus 2 cosine of theta equals 0. So when 2 cosine theta equals 1, or when cosine theta equals 1/2. Wow. So taking the inverse of both sides, right? This goes away, and theta has to equal between 0 and 2 pi. You will have two answers here. You will have two answers. So the first one I'm going to go with is the easy one, and that's going to be pi over 3. And since it's between 0 and 2 pi, let's see, 300. I always struggle with this one. So 300 let me change this to radians because I can't remember that one. So 300 over 180 equals x over pi. That's going to be x equals simplified. I have 50 pi over 6, 3. Okay, is that right? No, 5 pi over 3. 5 pi over 3. 5 pi over 3. Okay, so 5 pi over 3. That's my zeros right there. And you can check and make sure, and we did it in radians and not degrees, but in degrees, if you feel more comfortable, it's also this. But unfortunately, the AP classroom only accepts radians. So we're going to create our little sketch here. And I know that from 0 to 2 pi, okay, I have pi, I have pi over 2, and I have 3 pi over 2 right here, and then I have my pi over 3 here. I have my 5 pi over 3 right here. So I just put that on there just in general. It's not exact, but it works. So here are my zeros. That means I have a relative maximum or a relative minimum at these values here. So I'm just going to go ahead and figure out what those values are for f. So for f, I have f of pi over 3. And it won't tell me whether it's a minimum or a maximum, but it will tell me what the y values are at these particular extrema. So these are either maximums or minimums. So here I have pi over 3 plus 2 sine pi over 3. I have pi over 3, 5 pi over 3 plus 2 sine 5 pi over 3. Okay, so this equals and this equals. All right, so I'm just going to go put this in I have 2 sine pi over 3. And I'm going to put that in radians real quick. All right, and I have 2 sine 5 pi over 3. All right, and let's see what that is. 2 times square root of 3. Let's see if that's the same thing. And it is not. Let's try square root of 3. And there it is. Yeah. So what I have there, when I simplify this, what you have, let's go back. This simplifies to pi over 3 plus 2 times square root of 3, and I have pi over 3 minus 2 times square root of 3 over 2. And so my y values, I'm not going to simplify this all the way. My y values I have are I I have extrema at pi over 3, comma, pi over 3 plus square root of 3. I have another extrema at pi over 3, comma, pi over 3, no, 5 pi over 3, sorry, minus square root of 3. I don't know if it's a minimum or maximum for both of these. I didn't simplify it other than what's right here. Okay, so this is why we broke up the lesson, because it's just a lot of details that I had to go through. So here I'm finding locations of extrema. Okay, now increasing, decreasing. Let's look at that. Where is f of x increasing or decreasing? So increasing, when f prime of x is greater than 0, f of x is increasing on the interval. I'm going to put intervals. Let's go look. Okay, now decreasing, when f prime of x is less than 0, f of x is decreasing on the intervals. Okay, so let's go get some values here. So at f prime of 0, I have f prime of 0, let's see, f prime of 0, I have, let's see, 1 plus 2, and I get a 3, so it's positive. Okay, f prime of pi over 2, I get 0 right here, so I get 1. F prime of pi, I get a negative number, and I end up with -1. F prime of 3 pi over 2, I get a 0, and I get 1. At f prime of 2 pi, I get 1, and I get 3. Okay, so it returns back to where it was. So just looking at this, I have a 0, and I have a 0 right here. Then once I get past the 0, it changes from positive to a positive. Interesting. When it gets to pi, some interesting things happen here between pi over 2 and pi. It goes from that to a negative number. 3 pi over 2, it goes back to a positive number. 5 pi over 3, it goes to 0. At 2 pi, it goes to a positive number. So something weird happens. It goes from a positive to a positive here for f prime of x. So I'm confused about when it's increasing. Like, when does it stop increasing? So I'm going to go look at the graph. That's the best thing to do, of f prime of x first. So f prime of x. And the way I do this, I can do equals x plus 2 sine of x. Okay, wow. And only from 0 to 2 pi. So from 0 to 2 pi, For f prime of x, I can just plug it in like that, by the way, and it'll print it out. Oh, what happened? Oh, did that wrong. Less than x, less than 2 pi. Okay, so, did I still do it wrong? Yeah, there it is. All right, so as you can see, it actually prints this out. So I want to see what this 0 is. That's 2 pi over 3, and that's 4 pi over 3. So I did some stuff wrong here. I got the wrong zeros. First of all, that's what happened. I was wondering. So 2 pi over 3, that's like 120 degrees. So that should be actually right here. 2 pi over 3. I was wrong about that. This is my 0, and I have a 0 at 4 pi over 3. And this is pi. Here is, let's see here. Yeah, let me remap my thing here. Totally did that wrong. So guys, we were talking about whether or not Miss Smith makes mistakes, and I'm pretty sure I never, ever, ever make mistakes. I hope you didn't highlight. I feel like a jerk. Yeah, I'm totally a jerk. Let me get this highlighter out of here. Miss Smith is a jerk. It's official. I'm pretty sure you're gonna have fun like telling me what a jerk I am. Why is there so much highlighter here? Oh my god. Anyways, so dude, I totally did that my trig wrong. I don't know why I got that. Anyways, so oh, I didn't make it negative. That's why. Right here, guys, this is why you should follow all the steps. If you notice, I got 1/2 right there. I didn't subtract 1 on both sides. This would have gave me 2 cosine of theta equals -1. Divide both sides by 2. And take the cosine, the inverse cosine of each side, and theta then equals 2 pi over 3 and 4 pi over 3. I suck so bad. I am so sorry. All right, so this makes more sense. All right, and this is irrelevant because these answers are not effective for us. These don't work for us. These answers don't work for us. So we're going to go back and get those maximums and minimums. Hope you didn't use ink or pen. I can't believe I just spent like a billion minutes doing that. But as you notice, I only did those 2 problems for this lesson because they're pretty intense. But anyways, so our new zeros, because I suck so bad, right there. So we're going to look for f of 2 pi of 3 over 3, and we're going to look for f of 4 pi over 3. All right, but for the derivative, these are our zeros. So it makes more sense. So it's increasing when it changes from positive to negative. So from negative infinity to that first 0, union, it's increasing. And is it increasing anywhere else? Changes from negative to positive here, and it doesn't change back. Okay? It doesn't change back. It changes from positive to negative here. So it's increasing. Oh, well, let me rephrase what I'm saying. I'm thinking about yeah, negative infinity to 2 pi over 3. It's increasing. Interval's increasing. F is increasing because f of x is greater than 0. And then from 4 pi over 3 to infinity, it's also increasing. Glad I checked. Now, decreasing from the interval from 2 pi over 3 to 4 pi over 3. So all I need to know now is what these two values are. So I'm going to go to my table and plug them in. I have 2 pi over 3 and 4 pi over 3. And I got a minimum right here. I mean, a maximum right here at 2 pi over 3 and a minimum right here. How do I prove that? How do I prove that? So I have 3.8, and then I have 2 points. Go back to the graph. 3.82 and 2.47. 3.83 and 2.47. 3.83, 2.47. All right. So now I have that information. So at 2 pi over 3, at x equals 2 pi over 3, f has a maximum because f prime of x, the y values for f prime of x, change from positive to negative. From positive to negative. If I look, they change from positive to negative as they cross over the x-axis there. Location, have it, it's 2 pi over 3, comma, 3.83. Number next, it says at x equals 4 pi over 3, f has a minimum. Location is 4 pi over 3, comma, 2.47. And that's all she wrote. And when you come back, we should be doing this, but definitely do everything you can here. Have a good one, guys. All right, take care.